and this compound is open chain compound. And if you see a same carbon cis compound, that is in a you wanna see. Hello everyone, welcome to Toppers Academy. So in the previous lecture we were discussing regarding the basic concept of chemistry or organic chemistry actually. Yeah. So we have discussed how the branches of chemistry are being dealing like inorganic, organic, physical, and why we are studying this whole branch of chemistry as organic chemistry separately. The compound of carbon are being studied separately as a branch of organic. This thing we have discussed in the previous lecture, and we have also discussed regarding how we can represent these compounds of carbon. Various notations were there. We have discussed regarding the bond line notation. Sorry. We have discussed regarding the bond line notation, Lewis dot structure, condensed structure, and various other type of structure which are being shown by this organic compound. That all we have discussed in the previous lecture. Today we are going to discuss regarding the classification of these organic compounds. Yeah. So coming back to this classification, so as the first question is why we are studying this classification, because and why we are classifying this organic compound. So it is very important to study any compound if in a systematic way. So we need to classify them, because we know there are like how many compounds are there? Nearly 19 million compounds are there which are being formed from this carbon or carbon compound, or you can say organic compound. So to study a vast number of these compounds, we need to classify them. To study them then in a better way, we need to classify these organic compounds. So instead of that, the other compound, inorganic compound, except the element carbon and hydrogens, they are being termed as inorganic compound, and they are nearly 5 lakh only. So in the previous class also I told you nearly 97 to 99% of carbon compound are there. Nearly 97 to 98, you can say, if we are more precise, percent of compound are of carbon only. So this much a number of compound, 19 million nearly. So we have to classify them. So how we can classify them, that we are going to see. So there are various type of classifications are there. So firstly we are going to see the classification that is based on the structure. Structure based classification. In this type of classification, what we are going to do, we will first classify this organic compound into two classes. One is closed compound and another is open compound. These organic compound, they are being classified into two subclasses. One is open compound or another is closed compound. What does this mean, open or closed? You can say open chain compound. If you are going to know regarding the more precise way, it is open chain compound. And these are closed chain compound. These are closed chain compound. So two different type of compound we are going to see, and if I give you an example of these, open chain compound can be like this. This is, and the bond line structure of the what is the compound? It is the bond line structure of a compound. If you are not familiar with this, you can go through the previous video which we have uploaded regarding this you can say representation of organic compound, in which we have studied regarding the detail of this bond line structure. So this is like 1, 2, 3, 4, 5, 6. This is hexane, and this compound is open chain compound. And if we see a same carbon 6 compound, that is in a you wanna see closed chain. Again 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon and 6 carbon are there. So in this we will see that this 6 carbon chain compound, this is a closed chain compound. The chain is closing. So many more compound are there. We will discuss them a bit in detail. So just to show you how we can classify these compound to two classes. One is open chain compound and another is closed chain compound. Yeah. So these open chain and closed chain can be subdivided into various subclasses. So if you go into the detail of you can say open chain compound, or we call them by different name also. These open chain compound can also be named as like aliphatic compound or alicyclic compound. We are going to see these are also known as these closed chain compound. We also call them as cyclic compound because they are taking the shape of a cycle, which means the circular are there. So that's why we also call them as a cyclic compound. Or they are taking a structure of a ring type structure. The ring is being formed over here. So they are also termed as ring compound. These are the different names of these closed chain compound. Either you can call them as open chain compound, closed chain compound, or cyclic compound, or ring chain compound. And regarding this open chain compound, they are also known as acyclic, cyclic, and where the cyclic is not there, so you can call them as acyclic. This is cyclic, and we can also call them as acyclic. So these are just the different names, and these acyclic or open chain compound can be subdivided into different way. One can be branched, or other can be straight. And what does this implies? Branched and straight. To be more precise, we will call them as branched chain compound. And these straight will be termed as straight chain compound. So here a chain is going over there. So when the chain is going in the straight way, no branching is there. That type of compound is known as straight chain compound. So this is an example of straight chain compound. This is an example of straight chain compound. If you want to see some more example of the straight chain compound, it can be like this. This is a straight chain compound. The chain is going straight way, no other way. Or you can say this cycle, or many more compound like this. So it can be any number of carbon can be there. So this is the number of carbon. This joining part is number of carbon. It can consist of any number of carbon, but that must be moving in a straight direction, starting from here and ending at this point. But regarding this branch chain compound, if you want to see in a detail of these, so these branch chain compound, in the branch chain compound, this is the, you are calling it as a straight chain. If some branching is there like this, so this is a CH3 group again. If this is a another compound and two branching are there like this, like this. So any number of compound like example 1, example 2, example 3, these are the examples of branch chain compound where the chain is going in the straight way, some branches also there. So if you want to see which are the branches over here, this is the branch over here, sorry, not this is not the branch, that thing, yeah. Oh, I will make you understand this concept also, why we are not calling this as a branch. This is a branch. This thing we are going to study when we will study the nomenclature, and our upcoming lecture will be based on maybe the next lecture of after this, maybe we are going to deal regarding the nomenclature. Then we will study why we are considering this as a branch, not this. And in this case, any can be considered, this one or that one can be considered as a branch. So these are branched. This one is a branch. So this branch concept we are going to study in the upcoming slides or upcoming lectures, where we will study over here. This is a branch. This is a branch. This is a branch. So these are our branches. So these compound are branch chain compound. So it is this type of representation is based purely on, you can see the structure, the type of the structure. Over here also we have seen how the structure is in the simpler, this going in the same direction, in the straight chain only. That's why they are termed as straight chain compound, and the difference between straight chain compound and a branch chain compound is only the branching. Only the branching is the main difference between these two compounds. So now if we subdivide this cyclic compound, or you can say ring compound, or you can say cyclic compound, closed compound, or ring compound, if you want to subdivide these can be subdivided into alicyclic and aromatic. Cyclic compound can be subdivided into two important units: alicyclic and aromatic. So these are two type of this subdivision can be of two types, either alicyclic or aromatic. So two subdivision we have seen over here, and if we want to further subdivide these two compounds or these two subclasses, so there can be carbocyclic or heterocyclic. What is it? Much better. Homocyclic or heterocyclic. So the two cycles are there. So I have shown you in the previous slide, this is the cycle. So this cycle can be of two types, either it is homocyclic, either or heterocyclic. So as the name implies, homo means same. The same type of thing is going to repeat again and again. But hetero means some different things are going to take part in such type of compound. So yeah. So if we see the homocyclic compound, which means such type of compound, again and again we are going to see the repeating unit is going to be carbon. This is the homocyclic compound. This is the homocyclic compound, cyclopentane, cyclohexane. Cyclohexene. So these can also be subdivided into saturated or unsaturated. This homocyclic can be of saturated. So these are like saturated, these two, and this is unsaturated, where the unsaturation came into the effect. Yeah, sorry. So these were all the classification like homocyclic. same cyclic, same carbon is the repeating unit over here. But if we are having these compound like this, one O is there, some other compound like nitrogen is there, like this, two oxygen are there. So if some hetero compound, generally we are seeing nitrogen, sulfur, oxygen. These are the general compound which are being replaced by this carbon element. In heterocyclic compound, generally we are going to see nitrogen, sulfur, oxygen. So regarding the aromatic compound, these can be subdivided into three, you can say two units, benzoate, or it would be better if we take it to the next slide, or here also I will just, one is benzoate, so this can be like benzoate, and another will be non-benzoate. Benzoate, non-benzoate, and the third will be aromatic heterocyclic compound. Aromatic heterocyclic compound. So over here, if you see regarding this, so this heterocyclic, and what is the difference between this heterocyclic? This is alicyclic hetero compound, and this is aromatic heterocyclic compound. So this is the main difference between these two like heterocyclic compound. One is alicyclic heterocyclic compound or simple heterocyclic compound. Another is aromatic heterocyclic compound, or you can call it as non-aromatic heterocyclic compound. So this is the way how we classify. So we will study these three also in quite detail. So if we see regarding benzoate compound, so benzoate compound are such type of compound, organic compound that possess the benzene ring. This is our benzene ring. This is our benzene ring. If any compound contains a ring-like benzene in its structure, in its cyclic structure, such type of compound are known as benzoate compound. It can be benzene. The most famous example is naphthalene, anthracene. Many more examples can be taken. Benzene, naphthalene, anthracene. These are the benzoate compound. Over there, we are going to see the benzene ring is a part of an organic compound that is aromatic. And what is aromatic, if you want to know, we are going to discuss regarding this in the next video. It is quite sure we are going to discuss regarding this aromatic concept. What is the aromatic concept? We are going to discuss this in the next upcoming videos. Yeah. And regarding this non-benzoate compound, so these are such type of organic compound that doesn't have benzene ring. That doesn't have the benzene ring. Sorry. The benzene ring consists of 6 carbon, but here we are having 7 carbon, and it is also an aromatic compound. This is also an aromatic compound, but it doesn't contain a benzene ring. So any such compound which doesn't have a benzene ring in their structure, but they are aromatic, such compounds are known as non-benzoate compound. These are aromatic, but they doesn't possess the aromatic ring. And the third class is heterocyclic compound. These are aromatic compound which consist of aromatic, which doesn't. These are heterocyclic compound. These are aromatic. These are like you can say non-benzoate compound, and they possess, let's say, oxygen over here, like this. Heterocyclic and aromatic, like this. Like this. Like this. So all these are, you can very easily see that these are like cyclic compound. So if you go back to this cyclic, yes, aromatic, yes, benzoate, non-aromatic, heterocyclic, which means the hetero compound is there. Oxygen is there, sulfur is there, nitrogen is there, and their name are furan, thiophene, pyrrole, pyridine. So these are like these compound and these are aromatic. So it is a different class of this you can say organic compound. So this classification was based on purely structure of this organic compound. In the next upcoming lecture, we are going to see the various other way how we can classify these organic compounds. And I will just give you a view of what we are going to discuss in the next upcoming slide. We will discuss regarding what is iso, what is neo, what is primary, secondary, tertiary, quaternary. These all things, if you are curious to know about this, so the next thing we are going to deal in our like 1 degree, 2 degree, 3 degree, what are these? So this is also a basis of classification of this organic compound. We can classify on the basis of all these terms. So this thing we are going to discuss in the next upcoming lecture. So yeah. So and in this lecture, a quick revision I am going to tell you. So just we have what we have done. We have classified the organic compound into two units: acyclic and cyclic, and we also call this acyclic compound as open chain compound and cyclic compound as a ring compound or closed chain compound. These were subdivided into two units: branch chain and state chain. Branch chain where the branching is there, state chain where is no branching. And regarding this closed chain compound, these are also subdivided into two classes: alicyclic, aromatic. Alicyclic also subdivided into two units: homocyclic and heterocyclic, where the no hetero group is there, where the hetero group is there. In this class, three subdivisions: benzoate, non-benzoate and aromatic. For benzoate, benzene ring should be there. For non-benzoate, benzene ring should not be there. And for heterocyclic and heteroatom should be there. So this thing we have discussed in the today's lecture, and the next upcoming lecture we are going to discuss regarding this way how we can classify this organic compound. That's all for today. Thank you.